Okay, thank you so much, sir, for the opportunity. So today I'm presenting on pandas. So forgive the humble slides. It's my Quarto skills. I'm still honing them. So I use Quarto to render these slides for the presentation, and I've shared the link for people interested in seeing the slides.
Yeah, good. Thank
So
you. Let me add this one as well. We will teach you how to use Quattro. In our first cohort, we taught how to use Quattro to, do a lot of stuff. So, for example, the website that Lukman shared, we taught how we taught the cohort one how to create a website using what we call Quattro. So Quattro is one of the powerful tool that you can do many stuff. For example, you can see Lukman prepare slide with Quattro, which is a very good way to prepare slide, because as you can see, he will be able to run code in Quattro, a lot of stuff. So I will share the link, but we will see Quattro by the end of this data science. We'll have a session on how you can create a website for yourself, just like Lukman created his website. Every one of you will have his own website. It's not difficult. It's very easy. Yeah, we'll update this one in the GitHub proposal. This is the last part of data science. To communicate effectively, you need to have the website. Thank you. Lukman, over.
okay, thank you, sir. So today we are looking at pandas. In the morning, doctor explained NumPy. So NumPy and pandas are linked together, just as doctor explained in the morning. So the first thing is to talk about my objectives here. Is just to give an overview of pandas, what panda is capable of, what can be achieved with pandas, and then to hone down on some of the methods that you can use, some important methods as a starter, because we had a long session in the morning. So I want something that we can all take home. So after an overview, we'll go over some key functionalities, some key methods to understand in Pandas so that you can know how the data is, how to understand the data first before you can do the more complex things. So the first thing is what is Pandas? So Pandas is a Python library that's used for data analysis. So it's very robust. It has data structures like series and data frames. So, and the series and data frames make data manipulation more efficient and intuitive. So somebody will ask, why do we need to use pandas? So it simplifies handling of missing data, allows dynamic size changes for data sets, and offers powerful grouping capabilities, and includes extensive time series support. So somebody can ask, okay, what happened between the 1st of January this year and 31st of January? Maybe you have a data set that captures time. So with time series, you can be able to analyze and look at things with time. So this is something important. Another thing is, since we did NumPy, why are we doing pandas? Why pandas alongside NumPy? When we say, okay, NumPy is powerful, it's more low level. So why do we need to use pandas? So as human beings, we need to look at names and things we relate with. While computers needs numbers. So that's why whatever you have needs to be converted to numbers for computer. So that's why for pandas, you can see the names of things, and you can have mixture numbers and writings so that you can appreciate what you're doing, and then you pass it down as figures to NumPy, and NumPy does pass it down to the computer because the computer only understands numbers. And then pandas, like I said, we have two things. We have two data structures where you keep your data. Number one is series, and number two is data frame. So for series, is one dimensional. It's just one dimension with flexible indexing. So that indexing is important. So difference between a series and a NumPy array is that with a series you have index. So I can say I want to get the attendance of all the fellows in cohort 2. So I can put that in a series. All I need to do is put all the attendance in the series, and then the index will be your names. So maybe I have Abu Bakar, I have different names, then that will be the index. So if I want to reference it, I'll just reference the name and I get the attendance for that person. Then for data frame is two-dimensional. Data frame is two-dimensional. It's not a single column, it's two-dimensional. And then you have is size mutable, so you can change it, you can increase and reduce the size, and then it can take heterogeneous data types, so you can have different data type. Some will be numbers, some will be letters, different, some will be integers, whatever you have, you can do booleans and the rest. And then both structures have extensive methods that you can use on it. That's the whole point of pandas. So I have series which is one dimensional, and the one dimension has only one data type. And then for data frame is two-dimensional, and it has, so anybody that's used a spreadsheet before, maybe Excel, Google Sheet, and the rest, that just explains what data frame is. You have rows and columns, and then you can work on the data. So installing pandas is simple. You can install using pip, the package manager for Python, or using Conda. So whether using pip or Conda, you can install your pandas. Just that for Conda, you manage your environment and you also install. So it has more capabilities. So whatever you use is still okay. So the one that you know best is the best, obviously. And then importing pandas, it's alias as PD. So import pandas as PD. The reason you can import it as whatever you want, but if you use PD to be more consistent with documentation and other code you see online. So that's why it's advisable to import as PD. Or you can even do from pandas import star. So that means you're importing everything in pandas. But in that case, you won't know where your method is, the method you're using, whether it's from pandas or from NumPy or from matplotlib. So that's why you import as PD. So for series now, series is a one-dimensional array, but it has more functionality. And the reason it has more functionality is that it has methods, and there's also the index. The index means every name, every data item in a series has a name. So when we are looking at we said that in Python, everything is an object. So we know objects. To look at an object, we need to understand three things. So an object can contain data, and then can contain things that describe the data. Those things are attributes. So maybe a name, shape, ending, dimension, and the rest. And then it can also contain the things that work on the data. Those are the functions that work on the object, and we call those methods. So if you say something is an object, you expect that it has attributes which describe the data, and then we have methods which work on the data. So for series too, is the same thing. So we have a series, is an object, and then we have methods that can work on the series, and then we have attributes that describe it, maybe its name and other things. And then for data frame is two-dimensional. So to create it, for series to create is like written there, pd.series. Then you pass the array. Then that's how to create a series. You get a one-dimensional object. And if you don't pass the index, it's going to index it as numbers. So it starts from 0, 1, 2, 3. I start giving you, because it comes with an index. So each data point has a name. For data frame, the way to create a data frame is to pass in. There are several methods, but this way where you pass in a dictionary. So each key value pair is a column. So the key will be the name of the column, and the content, the value will be the content in the column, the data points in the column. So when you look at that, you have that's how to create a data frame. So somebody can ask, why do I need to create a data frame while I can just read a spreadsheet and get it? So it all depends on the analysis you're doing. There are times when you want to make a data frame yourself so that you can compare results of the analysis you make. So it's important to know how to create a data frame yourself. And then reading data, you can read data from different places. The most famous one is CSV. So you have read CSV, read underscore CSV, and then you pass in the file path, or even the URL. Maybe it's online. So you pass in the URL and you get your data read into Pandas. And we have other things. We have other data formats, maybe Parquet and other data formats. It's just read dash, read that, read Excel, read this. That's how they come. So the best way to know is just to check and experiment, check the documentation. And then the next is data exploration. I wanted to say, okay, so pandas have functions like head. Head is for seeing the top rows in a data frame. And then tail. Tail is for seeing the bottom rows in a data frame. And then describe. So describe is for a quick overview and statistical summary. So if you do describe, it's going to give you all the columns in your data frame, and it's going to give you the statistics, maybe the mean, median, and things like that. So the next one is data selection and indexing. So Pandas allows for easy data selection and indexing, whether selecting specific columns or slicing through rows. So in the lab, I will share that we'll go through now. We'll do the indexing and see how to create series and data frame. So to index, when you do data frame and you use your square brackets and put in this thing using and put in the column name, it's going to give you your column. And then when you do data frame and put through a numbers 0 to 3, in that case, you're going to see anyhow, if you put a single bracket, you're going to reference that particular column. So we're going to go into details in the notebook. And then data filtering. Filtering data can be done by passing in. So you have your square brackets and then you pass in. So in this particular code here is showing that we need all the data in column A that's greater than 0. So anything that's 0 or below, we don't need it. So anything greater than 0 is going to filter. So it's going to leave out the rest of the data and give you only the things above 0. And then grouping and aggregation. Grouping data based on different criteria. So you can, and aggregating functions. So what we mean by grouping is that maybe you have a data frame that contains different countries. So you group by countries so that the data will be related to each country. Before grouping, normally you have the data and then in a row you have Nigeria and then another one Ghana and the rest. So maybe you have 5 Nigeria, 7 Ghana, 8 US and the rest. So when you group by, it's going to give you the first column will be the countries and then all the other data will be aggregate. It's going to sum. So if you need sum, it's going to sum it. If you need mean, median or whatever, so you need to pass in an aggregate function, something that will maybe come sum, cumulative sum and things like that. Then it gives you what you need. So that's why it's important. And then also Pandas is so good that it integrates with matplotlib. So matplotlib is a library for data visualization. So with Pandas, you can just call plot method on the data frame and then you pass in. So with this, I can pass in kind equals to bar, and then it's going to give me a bar chart with the data in the data frame. So it's quite good. It's intuitive. You can use that to visualize, maybe simple visualization. Or if you need something more complex, then you have to use matplotlib or seaborn or other data visualization methods. So this is just an overview of Pandas to show all the things that Pandas is capable of. And the point is that we need to know the things that Pandas can do so that we'll be able to know. And the whole point, if you have a data set, you want to know what's inside, you want to know the relationship between all the different variables so that you can gain insights. And Pandas offers method to do that. So here I've attached resources, documentation, and then the book shared by Doctor, and then there's a Jupyter notebook that covers Pandas, just in beginning of Pandas. So thank you. And then I will move to the notebook where we'll see how to create series and run the code. Please, is my notebook visible?
Yes, it is visible, but at least if you can add, you can increase the font size so that it will be more visible to others.
Okay.
Yes, it is okay like that.
Okay. So this is discussing data frame and series. So we all know, like I said, there are two data structures in Pandas, data frame and series. So a data frame is two-dimensional, and then it's a tabular form, something that we are all used to mostly. So anybody that has worked with spreadsheets and things like that, maybe Excel, Google Sheets, you know what a data frame is because it's a two-dimensional and rows and columns. So normally the way they do it, each row is an observation and each column is an attribute. So each row is just like one instance of your data, and each column is just like an extra information on the data. So that's how normally it is, but it doesn't have to be that way, but that's the normal way. by default. So you can load a pandas data frame from existing storage. That's by using the read underscore CSV method. And then you can also, it doesn't have to be a CSV. It can be an SQL database or Excel file or even a package or different data formats. And then you can also create it from lists, dictionary, and from a list of dictionaries. So that's for the data frame. And then for series, it's one dimensional, like I said, it's one dimensional. And yes.
Lukman, it seems like there was a complaint. Somebody was saying you speak faster. Can you speak a bit slowly?
Okay. Okay, sorry. So for data frame is two dimensional, and then you can create them in different ways. You can create them by loading data set from existing storage. So you already have the data, you just want to load it. So it can be a CSV file or an SQL database or an Excel file. And then you can also create it yourself. You create the data frame yourself from list, dictionary, or from a list of dictionaries. And then for series are one dimensional. So by one dimensional is in one dimension. So it's just almost like a list, or let's say almost like a numpy array. Then it has two components, an array of actual data, and then an associated array of indices or data label. So you have the data and then the labels. So difference between a series and a numpy array is that in series, apart from the data, you have the indices or data labels. And by labels, it means each of the data has a name. So if you don't pass in a name while creating your series, Pandas is going to give it a name. It's going to give it numbers to represent the name. But if you want names, you pass it yourself. So that's different between a series and a numpy array. So to import the pandas library, you just do import pandas as PD, and then you're good to go. So like I said, there are different methods. So you can import star, and this is to import everything in pandas. So that means all the methods, everything, all the functions in pandas, you can use them without referencing anything. You don't need to write PD dot anything. You can just do. So if you want to do data frame, you can do just data frame without doing PD dot. But the disadvantage of this is that you can't know which library you're using. So you can have different names, different functions in different libraries. So you need to know which one so that other people can replicate your analysis. That's the whole point. And then you can also do import pandas like this. So but if you import pandas like this, it means for anything you want to do, you have to write pandas dot instead of just PD dot. So these are different methods of importing. And then some people can say, okay, because we do many imports, we can just say from pandas imports data frame and then series 2. So if you do that, because maybe you think you're going to create many series and many data frames, it will be too tiring to keep doing PD dot. So you can do that to just import. At least you know this data frame and series are from pandas. But this second one is not good practice because it gets everything complicated. So once we've imported the data, we can work on it. So for this one, I'm explaining how to create a pandas from a dictionary. So in dictionaries, you have key and then you have the value. So for this particular one, this name is the key. The name is the key, and you can see it's a string with quotation marks closing it. And then the value is a list of values. So the key, this name, and the list of values, the entire list like this, these 4 names, constitute one column. So this will be one column in our data frame. That's the number that goes vertically down. That's one column. Then the ID, the second one, that's the second key. And then the 4 numbers here, 1, 2, 3, 4. That will constitute another column. The ID will be the name of the column. The 1, 2, 3, 4 will be the data in the column. And then the third one, department, that's the third key in the dictionary. And then the values, we have them, architects and the rest. All these values 4. And they have to match. If they don't match, Pandas will find a way to make it work. But at least if they match, your data will make sense. So for the fourth one, salary, that was the last one. We have that's the key, and then the values now is the list that we have, the value. So key value pairs dictionary. So if you pass key value pairs, you're going to have a dictionary. And when you run this, the name is this, and then you get this. So you see the name is the name of the column, and then the values come down. So each key value pair will give you a column. Key value pair will give a column. So name, ID, department, salary. So when you see dictionary, each key value pair will give this thing a column. And then here you have the indices. So 0, 1, 2, 3, 4. So in Pandas, everything has a name. And then here the column name will be from the keys of dictionary. So name, ID, department, salary. And then column selection. So if you have a data frame, you want to select the column. Maybe you're not interested in everything. You want to select each column. So if you want to reference and select a column, you pass in the data within square brackets. So you put df and then you pass in the ID. So when you do that, you get the answer. So you can use one bracket or two brackets, depending. But if you use two, like, okay, this is ID and this type is this. So when you use one bracket, it's going to give you a series, but two brackets, you get a data frame. So this is just this thing. And then the next one is type. So you want to know the type, and then you get the type. So it's a Pandas data frame. So here, but let me change it to one square bracket, changing it to one square bracket, and then let's check the type now. So a series. So if you want to get a data frame or series, number of brackets, as long as it's one column. But if it's more than one column, of course, you're going to get a data frame, because data frame is the one that is multidimensional. Then access to multiple columns. So if you want to get multiple columns, you can put the multiple names in a list. So you have the first column for referencing and the second column as a list. The first square bracket, sorry, as for referencing, and the second square bracket as a list. So you have department, salary, ID, pass in as a list inside the square brackets that's there for referencing, and then for retrieving it. And then once you do it, you're going to get the content. So the reason we need all these things is because we want to check when you have data, each of the columns represent attributes of the data. There are different content of the data, and so you want to look at each of the column. Maybe you want to plot it, or there are specific things you need to do. So you find that when you're learning something and you understand why it's important, it helps you remember. So the next thing is, okay, this is a data frame, and then it was asked. So I can share the empty one for people that want to just try doing this. So, but I know there's no time to do. That's why I feel this. So for data frame, if you understand how to create it, so with the picture like this, you'll be able to create the data frame yourself, like this, the way it is. So
Hi, Lukman, question. Hello? Hello?
Yes, sir, you can audible. Maybe his network is somehow, but you can ask the question.
Okay.
so the key point is that you pass in a dictionary.
Look,
Hello,
Okay,
sir.
Lukman, sorry, doctor has a question, please.
Yeah, Lukman, somebody is asking, why do we use DF? So maybe you need to just explain a bit what is data frame, so that we just use DF. Maybe, I don't know, you can tell him why we use just DF. Like he's asking, you are always using DF as your variable name. So maybe you can start with what is even data frame, so you should know what is data frame.
Okay, sir. So here, so like I explained, data frame is a data structure in Pandas. So it comes in rows and column. So my understanding is that the person asking knows about data frame at least, but let's explain. So it comes in rows and column. So data frame is two-dimensional, unlike series that are one-dimensional. So you have rows, which normally refer to instances of your data, and then the columns, which are the attributes or the particular information on each specific example. So for instance, this particular picture is a data frame. So here we have the rows. The rows is reading from 0 to 85, 1 to 72, 2 to 89, and then 3 to 76. And then for the columns, you go down: students to Ivan, age to 32, country to USA, course to web development, marks to 76. So those are the rows and columns, and that's what a data frame is. It's a collection of data arranged in rows and columns. Regarding using DF, let's say, it's something that is common. People use data frame normally, but you can use whatever you want to represent your data frame. For instance, just today I did one analysis and I just named them normally. So I just did COVID data and things like that, just naming them the way I want to understand it. So regarding the DF, you can name it whatever you want. But if you're just using one data frame and it's just for this thing, you can just use DF to name your data frame, or you can name it however you want. You can name it Pandas, you can name it student, you can name it your name. The most important thing is that it should have meaning. It should mean something so that others can relate to it as you define Python variables. Thank you. So the next thing is, okay, this is just like a review. So if you want to retrieve a column, like I said, you can retrieve it in two ways. But if it's a single column, so by using one square bracket or two square bracket, one square bracket will give you a series and two square bracket will give you a data frame. So depending on what you want as your output, you can do that. And then here too is also a review, retrieving more than one column. So if you want to retrieve more than one column, you can't do one bracket. It has to be two brackets, because the first square bracket is for actually referencing it. The second one is for the list, because you're passing a list of columns to retrieve two columns. So you do that. And then the next one is if you want to view a column as a series, like I said, you just use one square bracket. So all these things, I'm repeating them because they're important. This is something that somebody is going to be doing all the time as you're working with Pandas. So the next thing is, this is highly important, lock and iLock functions. These are methods for selecting data in data frames. So if you have been using Pandas, you'll notice that maybe if you do some assigning and the rest, they will actually, you should use lock, or you should use iLock, you should use lock to reference. So this is something that maybe the older versions of Pandas are moving, the newer versions of Pandas are moving away from regular referencing. So you need to understand lock and iLock so that you can be able to select your data from the data frame. So we have to, for lock is label based. So what I mean by label based is, we all said that everything in Pandas is labeled. So your series have a name, your data frame has a name. So like I said, for the data frame, it has a name. So if you check this particular data frame, country, course, the names are this 0, 1, 2, 3. These are the names of the rows. For the columns, the name of the columns are country and course. So if I want to use log to reference, using log LOC to reference, I will pass in numbers to represent my rows, and then I'll pass in these names, country and course, to represent my column. So that's lock method. So for lock, you pass in the row label and the column label, and then don't use round brackets. Always make sure you use square bracket. So when you use the lock method, you use square bracket because you're actually selecting. It's not a normal function. So some people make the mistake of using round brackets. So it's always square brackets. Then the next one is iLock. So iLock is index based. And by index based, let's go back to the same data frame here. So by index based, we mean you start from here, the first row now, the first row 0 to 3. So in iLock is integer. So it's index based. You start from, this is row 0, row 1, row 2, and row 3. So it's just a coincidence that the names have the same the rows have the same name here, but in X. So for the column here, this is where it will be the method. You're just going to pass in country and cost, and the columns too. So the log is easier to use because the index, the particular, there's zero indexing in Python. You start from 0, 1, depending on the number of columns. So for these two, let's check. So if you want to do access the value on the first row of the first column, first row, the first one is the row, that's 0, and then the second one is the column, that's 1. So row 0, column 0 is going to give you one item, the value. So that's the name. And then the second one, the value on the first row and third column. First row and third column. So we are using iLock now. Value on the first row and third column. So first row is 0, third column is 2, and then we have the value. So the next one is access the column using the name. So if you want to access using name instead of index, it means we are going to use the lock method. That's LOC. So if you want to access the column, then you use lock method. So the reason why I use 0 is because the actual row is labeled 0. So that's why we use 0 here. And then the column is the name, salary. So the next one is DF. We are going to do, okay, we are creating a new data frame, DF, and then assigning to it. And then we'll set the name column as index using the method set index. So in data frame, there's set index method. So by set index, it means you're going to assign the index. So in data frame, when we say index, normally we mean the name of the rows. And when we say columns, we mean the name of the columns. But index as an object can stand for row and column. But when we just say index as a name, we are talking about the rows, the name of the rows. So like for data frame we've been looking at, the rows are not named. So it has numbers as names. So what we are trying to do here is to set the name, set index as name. So then df2.head, and then now we have, so the index of the data frame now is the names. So we have the index of the data frame. So the first row now is no longer number 1, it's named Lukman. So you see the first row, and then the other columns now will be normal. So we have 3 columns instead of 4 now, because the first column has become the index, is the label of the rows. And then, so if you want to access the column using name now, access the column using name, you're going to put the name and you're going to put the name. So for this part data frame we have to access this thing. So let's say we want to know this thing, the second row, the salary of the person in the second row. So for the salary of the person in the second row, we put in the name of the person, because in lock we use the name, the label of the row, you don't use the number. So for that we pass in, and then we have the information. So, and then the next thing is, if we want to do, let's say I want to use iLog for this particular thing. So if I want to use iLog, I need to pass in numbers now. So for this same thing, I'm going to pass in 1, and then for the salary is 0, 1, 2. So, and this is 0, 1. So if I put 1 as 0 here, 1, and then 2 with iLog, 1 and 2. So I'm going to have the same 80,000. So that's the difference between log and iLog. And then another thing to note is that with log and iLog, it's not just for getting the values. You can also get slices. So let's proceed. So if you want to slice the data frame, you want to get some pieces of it, not the complete one, depending on places, use index. So I want to get from the second row to the 5th row. And then the second column to the 3rd column. So that's a slice. So with that too, you also need to know that we can use lock and iLock for it. We can use lock and iLock to select the same way we did for individual values here. We can use lock and iLock, but the difference is you have to know. So you have to check your data frame. That's why those methods like df.head will help you see, okay, this is The first row is this, the second row is this, third row is this, the column is this. These are the names. So once you understand that, you'll be able to continue. So for referencing, so if I want to reference now, iLog, I want to slice. So for this one, this first number
Hello, Lukman. It seems like you are not audible, please.
number getting from the first row 0 to 2. So the question now is this. So is my network. Hello, please, am I audible?
Yes, you are audible and clear.
Okay. So let me just wrap up. So that's why I said we're only going to look at a few methods that are important. So the reason I'm dwelling on this is that we need to understand the data first before we can do any manipulation on it. So we're talking about two methods for understanding, for referencing the data and for slicing, log and ilog. So we said that if you use the log method, is we are going to pass in the name, the labels. So like we said, in a data frame, the rows and the columns, they all have names. So the names of the rows are called indices. So this is 0, 1, 2, that's the name. And then for the columns, here we have ID and department. So if you want to use the actual names of the rows and column, you use the log method. So df.log 0 to 2 means I'm going to get rows in the first and second rows, because Python has zero indexing. And also this is exclusive, the last digit is not captured, so it's not going to give you the index 2. And then the second one is here, ID to department. So for this one, we have ID, and then we have ID and department. So sorry, for the lock method, it's going to capture everything, is the name. It's going to capture everything. So from 0, 1, 2, you have 0 to 2, and then ID and department. Both ID and department are captured. So it's not going to follow the regular slicing for Python. So ID and department will be captured, and then 0, 1 for the log. And then the next one, so the essence is to differentiate between log and ilog. And the reason we have these differences is that sometimes you have the naming as names, you have the namings as numbers. So you need to tell Pandas, I'm giving you the numbers, or I'm giving you the name, so that it can differentiate. Because if you actually name them with numbers and they are not arranged, it's going to cause confusion. So maybe the first row is 1, and then the third one is 3, and then you pass in 0 to 2, it's going to be confused. But if you pass in ilog, it knows it's going to just use the number. So row 0, row 1, and then you get that. But if you pass in the log, you know that it's going to deal with only the labels. So the fact that you pass in 0 to 2 means the rows actually have those names as their labels. So I think this is so basically log and ilog, how to create series and data frame. So that's all I have. Thank you.
Okay, thank you very much, Lukman. Yeah, thank you very much, Lukman, for this. Anyone with question? Anyone with question? Okay, So if there is no question, let me quickly share my screen just to show us something we can go home with this week.
Excuse me.
Yes.
I have some questions.
Okay.
Or say some addition that I will require, if possibly. We haven't seen how to manipulate some data using the pandas, such like deletings, how to handle missing data, and so many stuff using the data frames.
Right. Yeah. So this is important. So I think what we will be able to see is that we'll be able to see. Let me share my screen. So this is, I believe this now, what it gives us is just like the basics of pandas, right? How to use pandas, how to do this and whatsoever. Now, the next thing is, how can you apply this basic knowledge of pandas that we now understand, do data analysis? So what you are saying is like how to remove missing values, how to do whatsoever. That is data, a way to say we are doing data analysis, right? So let me share this screen so that maybe we'll be able to. That's a good question, because like at the end of the day, what we'll be doing is basically this stuff. Okay. Okay. Right. Can you see my screen?
Yes, sir.
Okay. Cool. So what we'll be able to see, he's asking like, okay, we understand pandas now, but we haven't looked at some of the stuff we will do. But if you look at, for example, this session, the reason why we make it like, not to continue with some part of this, because it involves some knowledge of pandas. So for example, working with the Python and preparing data. So if you look at, okay, this one, okay, so if you look at this one here, for example, it start discussing about series, and we didn't discuss pandas and numpy. So they even start discussing data frame. Can you see data frame? So that means now we get the basics of, all this stuff. We can dive in and learn them. Getting the data, you can see use the read CSV, how you can print and, working with unstructured data, right? So if you go back again and preparing data, if you can hear common cleaning goals. So important of cleaning data. So this is where we apply the knowledge skills we learn for pandas. So why do we clean data? Ease of use, consistency. Now, common cleaning data. Some of the things you need to clean data: exploring the data set, formatting the data, duplication, removing duplicate, removing missing data. So you can see now here, you learn how to remove missing data, how to remove duplicate, dealing with missing data. You can see them, removing duplicates. So yeah, so this is what I wanted us not to discuss in this session, but to have the knowledge of pandas and then move to them. So in our next session, though we haven't, thank you for bringing this back as well. What we will be able to do is we'll go back to this understanding data, even yourself, because you already have this document. The fellows, you already have this document. You can quickly come over here and start going through this, this part, working with data, preparing data. But definitely we'll come back to them and, work with them to make sure that you understand. So, yeah. But one thing I would like to add as well is that you can see here we talk about, NumPy. Okay, this is NumPy, right? Okay, this is NumPy. I have some stuff that you'll be able to practice. So for example, here, this is NumPy notebook. So what I discussed today in the morning, if you click NumPy notebook, you'll be able to see it here. So you can see what I have discussed today in NumPy, what we can do with NumPy. So this is the lessons, but also as part of what you can try to do this week is practice exercise. So you can look at this one, NumPy 100 exercises, NumPy 100 exercises. So what this means that these are exercises that you can try yourself to make sure you get up to speed with NumPy, Pandas, NumPy. Import the NumPy package under the name NP. So this is a question, how can you import NumPy under NP? So you can see what we can do is import NumPy as NP, right? So this is basically print the NumPy version and configuration. So how can we print NumPy version in our computer? So sometimes, you need to know what kind of version of the package you are working on. Who can tell us how to print, NumPy version? Who can tell us how we can print version of a package we are working on? Anybody can volunteer? How can print version of a package you are working on? Okay, Umar Shehu. Okay, Umar Shehu gave us this. We said NumPy. So you can see NumPy version. Can you see that? So it tells you the version of NumPy you are working is 1.22.4, right? So this is some, maybe you don't know, we didn't teach this stuff, but as you come trying to do this exercise, you will learn a lot. You know what I mean? So these are exercises that you try. Will not enforce this one, but if you want to learn, the only way to learn is just practice. And we are here to guide you to say, okay, do this. We give you the road and show you the road and, make yourself better. That is for NumPy. We also have, Pandas exercises. So this is what Lukman just finished. Pandas. When you do that, you can see, look at this, Pandas exercise. So if you open Pandas exercise, so what I say, like this practice, if you come here, you say you want to do this exercise, if you don't know how to do something, just ask it in your group. Somebody can help you. Or if he doesn't know, he can ask. Or just disturb your mentor in your group. Always ask questions, you'll be able to learn. The more you practice, the more this stuff. You don't need to cram anything in data science. You don't need to cram anything. The only way to stick into your memory is just practice them. So if you come to Pandas as well, we have a lot of exercises for practicing exercise. So you can see this is a repository with exercises and solution impact. So for example, lessons, getting and knowing, how to know data, Pandas, for example. You can see getting and knowing. This is an example, the exercise of the exercises. You can see the exercises with solution, and you can see exercise only. So getting to know that. Import necessary libraries. How can you import? You can see this. Importing the data set from this address. So how can you import data set? So you can see this is an example. They give the URL of the data, where the data is. It's a TSB file. Now you can see that we read the TSB, pd.read.csv. You provide the URL. And because this is not CSV, you need to provide this /t. That is mean you are reading TSB file. So you can see the first 10 rows. You can see the question, see the first 10 rows. So this is, let me show you. Okay, this is the exercises, and each one is the question. Import necessary libraries. So look at this time we are going to pull data directly from internet. So this is the, question, pull data directly from internet. And you can see they have video tutorial maybe. So now these are the necessary, libraries to import, Pandas and NumPy. Import them from this address. This is what we use. We assign them to a particular repository. And now see the first 10 entries. Lukman made mention we use head. You can see them first step. What is the number of observation in the data set? So how many observation do we have in the data set? When we say observation, how many rows do we have? For example, order ID, quantity, item name, choice description, price. So how many do we have? Yeah, now we see top 10. Now, so you can use this shape 0 to show you the number of items. You remember I discussed previously, like, okay, what is shape? In our today's session, we talk about shape. Let me see something like it. Let me show us this example. We talk about the shape, right? Okay, let me use this opportunity. This one. Let me put this. So this is this. Okay, this is it, right? So this is array. Now, what is the shape of this array? We can see that if we take this array that shape, you can see it returned 2 by 3, right? But if you want to know how many rows do you have, so you can call extract the first one here. You can say, okay, shape 0. You can see it give you 2. It means it tells you how many rows you have. For example, here we have 2. Can you see that? So this is what this is telling you. See shape and 0 interest. So some stuff will not be able to teach this stuff all in and what is the information about the data set. You can call on the data program info. Can you see info? When you call info on the data program, you can tell you how many row you have, how many order ID you have, how many all information. What is the number of columns in the data set? Can you see that? You can see one. You access the first one. So here, when I said, okay, you see how many columns do I have? 1, 2, 3, right? So if I want to say, if I put 1, it will give me, you can see 3. You can see I have 3 number. So you see, like, you can learn a lot by practicing. You may not be able to. So this is something that you can practice yourself. A lot, how to do filter and sort data, how to do grouping, how to match data set, how to do visualization, how to do deleting, all this stuff. So you can practice the one, you can select and practice. And yeah, that is one. Let me go back. Okay. That is Pandas exam. I will also upload today's Lukman, upload your NumPy notebook. You can see here I put NumPy, upload the Pandas notebook here as well, so that this one will be able to do that. I will also quickly today immediately upload the recordings for NumPy in the morning and Pandas today in the afternoon. I will upload that one. Yeah. Any other question? Any question? Any question? Okay, without question, let me quickly show you one thing that may be useful in your VS Code experience. So if you go to, you can see something like this code. It's called Project Manager. Project Manager. What this means, if I click on it here, you will see all my files and folders on my VS Code. All these projects, I have them and I save them. So if I want to open this one, I'll quickly open this one. So if you come here, just type Project Manager, you can see this one. You can install it. When you install it, you can see I already installed it. Now, the advantage of this one is that you'll be able to store all your, you don't need to go back and open project, in your VS Code and whatever. You'll be able to just use it. For example, if I open, you look at the folder I am in now, right now, this folder. So if I want to save it so that I will quickly reference it here, what you need to do is go to, go to the, here, and then type save project manager. You can see project. So you can see here, project manager, save the project, save a project. So when I say save a project, you can see RODS machine learning. Yes, I say save it. So all this folder, RODS machine learning, it will now be here. RODS machine. Can you see RODS machine learning? So whenever I open VS Code, as I click here, it will open a project manager. So when I click here, it will automatically open project manager file. So for example, here, maybe big book of PHP, I open it. Can you see that now it opened my big book of PHP in another, VS Code. So this is a cool package that you can use to, organize your projects that you have. You don't need to have them, in a different location. You can save them here. Okay, so this is one thing that I wanted to, add on top of your VS Code is, a very good package. Yeah, so let me stop here. It's already 3 o'clock. You can ask question if you have. Yeah, any question? Any question? Okay, Yahya Muhammad, go on. Yahya Muhammad, go on. Oh, you cannot unmute yourself. Okay, let me think. Let me see. Unmute. Okay, you can unmute yourself now.
Yes, I muted him.
So, my mine is not a question. It's pertaining to the morning class, sir.
Okay.
So what we saw in our mail was that the class was to hold by 2 p.m. So unfortunately, when I later on went online around 2, then I saw that the class hold by in the morning. Maybe, sir, maybe next time, maybe, sir, maybe let us be told before time so that we can attend both the two, sir.
Yeah, so it was a mistake that an email has been sent. We already communicated. We are gonna, if you look at it in your Telegram group, we have 2 sessions today. We said 10 a.m. NumPy and Pandas 2 p.m. So unfortunately, Saminu, he sent an email with 2 p.m. And when we joined, I quickly log into the email and send. We are meeting now, not 2 p.m. at 10 a.m. So, however, we already have the recordings, and it will be ready as soon as possible today, so you can watch the recording. I highly recommend this 2 sessions today, NumPy and Pandas. Try this week to try to master. This is incredibly most of the important part of your data science journey. NumPy and Pandas. If you might master them, you finish your all problem you'll face in data analysis in Python. You'll have no issue with them. Yeah.
Right. Thank you, sir.
Okay. Anyone with question?
Yes, sir. Hello.
Yeah.
Yes, sir. My question is, if we are calling a file that is from the DF data frame, we want to call a file, and it's not in CSV format, is there any way that we have to we can convert it to a CSV format before calling from the data frame?
So it is in which format? Tell us the format that it is.
There is an example that you showed us. It was not in CSV
Yeah.
format.
So yes, so the example I showed, it is CSV tab separated. So when you are reading, you say read CSV. There is argument for that function. Read CSV has an argument to specify what kind of file it is. If it is CSV, you just read it without argument. But if it is tab separated file CSV, you need to specify what kind of argument is it, what kind of file is it. So you say it's CSV, so you can read it normally.
Okay. Thank you, sir.
Yeah, is there any method that can be used to get data from bottom like the head? Yes, tell. So you can use tell, I think, right? You can use tell to get data from the bottom, if I'm not wrong, right? You can use tell. Yeah, so you can use tell. So Lukman, you are the data, you did the Pandas. So if you want to, she is asking, can you use a method to get data from the bottom? Lukman, can you answer her?
Oh yes, you can do that using tail method. And then if you want specific number of rows, you can put the number as an argument. So maybe tail, and within the bracket you add 10. So maybe you want the 10 last rows in the data frame.
All right, thank you very much. Anyone with question again? All right, so thank you very much for joining us. Do check back soon. We'll be able to upload the recordings for tomorrow, for today in the morning, and also this session. Yeah. All right. So if there is no question, do please practice these exercises. NumPy and Pandas, they are there. It's gonna be good for you. And in fact, you can push them in your GitHub repository. Yeah, we'll upload the NumPy recording soon, inshallah. All right. Thank you very much for joining us, and we'll see you next week. Bye-bye.
Thank you, sir.
Thank you, sir.